share. And I want to ask you guys, does anybody know why this past Sunday, don't say it out loud, why this past Sunday was a special, special day for mathematicians around the world? And I'm gonna, oh my God, lots and lots of hands are up. Everybody say it on 3. 1, 2, 3, go.
It was Pi Day.
3.141592653.
Who can explain why this past Sunday was Pi Day? Jonah?
Because this past Sunday was March 14th, and the first 3 digits of pi are 3.14.
Right, guys. March 14th. Now, everybody go to page 1 right now.
Mr. Krim.
Yes. Somebody.
So I memorized the first 55 digits of pi.
Well, you're going to learn a lot today about pi. But the first thing I want to do, that's awesome. But I want you to do, everybody, I want you to draw the symbol pi. Does anybody know where the symbol pi comes from? Does anybody know where the symbol pi comes from? Raise your hand if you can share that. Where the symbol pi comes from. And I see, I don't know if Penny's raising her hand. Does anybody know? And I know Jonah has an idea. How about you, Alexander?
It comes from ancient times, doesn't it? Ancient Greeks.
Well, actually, pi is a Greek letter. It happens to be the 19th Greek letter, but pi has not been known as 3.14 for many, many years. So let's go to Jesse now.
I'll say something about.
You'll have to speak up very clearly, Jesse.
Like Greek or Latin or something over there.
I heard Greek word. Jesse, can you speak a little more clearly, buddy?
Yeah, I was thinking about Greek or something.
Oh, good.
Yeah.
Now, guys, it is a Greek letter. And Jonah, what do you know about the symbol pi?
Well, I was gonna say, yeah, it came from the Greek letter,
And it corresponds with our letter P. So if you hit option P on your computer, do you know that you get the symbol pi?
Yes.
If you want to try that,
wow,
you can. Or if you want to draw the symbol, just draw an 11 and then a little squiggly on top of it, which is a great way of drawing pi. Now, guys, mathematicians have been studying the value of pi probably for more than 5,000 years.
I saw that.
Oh, somebody's yelling in the background there.
Yeah.
So let's see if that person can mute themselves. Okay, so everybody doesn't have to hear that. Now, I know for sure that people have been studying pi for over 5,000 years. Do you know why I know that?
Why?
Because the relationship between the circumference of a circle and its diameter was discussed in the Bible. And in the Bible, it says that the value of that relationship was 3. And man, were they wrong. The Chinese also estimated it was 3 over 5,000 years ago. But it wasn't until Sir Isaac Newton. Now, Sir Isaac Newton, he was the first one to use decimals to find pi. Now, Archimedes, a famous Greek mathematician, he used a different method that I will describe later, and he got pretty close, but not close enough. Now, in the year 1706, a mathematician named William Jones, who was from Wales, near England, he came up with, hey, let's call this thing pi. Because before that, this is what they had to say. They had to say that pi was the quantity which, when the diameter is multiplied by it, yields the circumference. And man, was that a mouthful. So I'm so happy that they started using the symbol pi. Now, everybody move to page 2 in their packet. Now, on page 2, I am going to introduce to you something called the unit square. Now, I've talked about this the last few weeks, where we talked about, guys, look at this right now, the area of a 1 by 1 square. Who can tell me the area of a 1 by 1 square? Go ahead, Mark.
2.
Not 2.
1.
Can somebody else do it?
1.
1 square unit.
Guys, it's 1 square unit. Please don't call it out next time. The area of a unit square, guys, is 1 by 1. 1 times 1, which is 1. Now, how many square units of size 1 by 1 can fit in a unit circle? A unit circle has a radius of 1. So I want everybody, nobody call it out. And watch what I'm going to do, guys. Before you answer this question, I'm going to ask people to tell me, is the answer more or less than 4 square units? On 3. 1, 2, 3.
Less.
Less.
It is less. Because as you can see, there's all of this excess that has to be subtracted from 4. Now, who has a really good estimate of the area? Hold on 1 second, guys, and I want you to write it down. Send me a chat right now.
Okay.
I'm not really sure.
Mr. Kramer,
Yes, question.
I have a question. Are we trying to count the individual square units for each square or all together?
Well, they've got to be, and sometimes when something, remember when we did Pick's theorem last week and we looked at very strange polygons, and the squares didn't fit perfectly into them, but we found the actual area, the actual number of square units. Now, by the way, one person has hit a number several times. I don't want to call it out, but that person can't do that. You only enter the number once. Now, I got some really good answers here.
Well,
Really good answers. But I
got
only
answer, but
have
I-
one answer. I only have one answer that is accurate. I had 2 answers, one answer that's really close. Now, a lot of you answered 3, which was the number that we know was used in the Bible. But it is actually more than 3. Now, Mark came up with something that was also incredibly close. Mark, what was your answer?
3.17.
Now, 3.17 is today Pi Day, March 17th?
Yeah. No.
Pi Day was Sunday. March what?
14th.
Right. So the answer is, guys, 3.14 square units. But the actual answer is pi. Now, what Mark may have been thinking of is that pi is very close to 3.17. Now, believe it or not, guys, the Babylonians came really, really close thousands of years ago. The Babylonians got to 3.18. Really, really cool. Archimedes got to 3.06. And then everybody now pick up a calculator. Does everybody have a calculator handy?
I don't have a real calculator, but I have like this computer calculator.
That is as real as any calculator.
Wait, can I say something?
Yes.
I have both my computer's calculator and I have a real calculator, so.
I would like for you to look at your computer or real calculator, and I want you to find the pi button on it. If
I
you
found it.
find the pi button, hit it, and don't say what it is, but you can show it on your screen.
Mr. Kramer,
Yes.
some calculators don't have a pi button.
If it doesn't have a pi button, try to use your computer calculator or your iPad calculator or your iPhone calculator, all of which has a pi button.
I still don't have a pi button.
You should. You should. Now, hit the number pi.
Mr. Kramer, can I say something?
Yes.
So on mine, so whenever I click the pi button, a game pops up, and it's kind of a memory game to see how many digits of pi you can remember. So I'm not gonna play it. I'm gonna pause it, but
Well,
I accidentally started it. So.
But we know that Jonah could answer 55 digits. Now, everybody, look to page 4 in my packet. Did your answer look anything like 0.141592653589793?
It looked exactly like it.
Awesome. By the way,
3.14159265336.
7.
wait a minute. Hold on a second. Jonah, yours is different?
No.
Mine is different too.
Mine isn't different. I didn't use my calculator, but I know 55 digits of pi by heart.
Can you give me the first 16, please?
Okay. 3.141592653589793.
That's 15.
Oh, a 932.
Good. Wow. So Jonah does know at least the first 16. Now, what was really cool, in 1665, Sir Isaac Newton, who invented calculus, he figured pi to 16 digits, which is what we are showing right now. Now, believe it or not, about 50 years later, a man named Tom Lagney, he figured 127 decimals, and then one of the first computers in around 1950 broke the record and got up to 500,000 digits of pi, and then that record was broken in 2017, 4 years ago. 22 trillion digits of pi. And who can what is special about the digits after the 3 on pi? Mark?
My
My pi number is different.
Tell me what it is.
3.14.14159265636.
Ah, your
Mm.
calculator runs out of digits right over here, Mark. So what it does is when it looks at the 5 and then it looks at the 8, it rounds up the 5 to 8 because it has no more digits. That's why you have a 6 instead of a 5. Does that make sense?
Yeah.
It's the way your calculator rounds. Now, guys, who can tell me what is funny about the numbers 14159265358979932? What's funny about it, Jack?
They're all odd numbers.
Well, there's a lot of odd numbers, but the
Two is
4
not an odd number.
and the 6 and the 8
Yeah.
are all even. But you know what's interesting, Jack, is that there's more odd digits than even digits. That's a very, very interesting fact. I've never really noticed that, Jack. Thank you. Does anybody notice anything else? Go ahead, John.
It's infinite.
Well, that's not something you can notice from what you're seeing. So what do you mean?
Oh, it's random. There's no pattern.
Ah, it's not random,
Oh,
but there is no pattern. So if you understand, it will never stop.
It kind
It
of
will never have, hold on. It will never have a pattern. It will go on and on forever. And what we do after the last digit is we write a dot, dot, dot.
wait. What about 535? I think these like 535. That because that's
Hold on one second. Pi, we would write, everybody write it. Pi equals 3.14 and then dot, dot, dot. The dot, dot, dot means that there's no pattern, there's no pattern, and it goes on forever. And we've only found 22 digits. I'm sorry, 22 trillion digits of pi, but we know that they go on forever. We just don't have computers big enough to go beyond 22 trillion digits. Now, somebody said that they thought they found a pattern. Who thinks that they found a pattern in the digits?
Jack does.
Go ahead, Jack.
So, 3.14141. It's 141. 141.
Jack, does that
It's
continue after 141?
No.
So it's a great, for instance, Jack, do you also see 535?
Yes.
Do you also see
Also 97.
979? Okay,
Yeah.
so that exists in different places, but that doesn't tell us what the next digit is going to be. But Jack, that was a beautiful and accurate observation. Now, who would like to find pi the way the ancient mathematicians did it? I would. Everybody now, please go to page 6. On page 6 of the packet, you will see that I drew a circle and then I drew a line called a diameter. Now, I'm gonna hold up a plate that I have. Hold on a second, I'm gonna be able to see what I'm showing.
I have a CD.
Everybody watch Mr. Kramer's first. Okay, you ready? I've got a plate, and what I'm gonna do is I'm gonna take my measuring tape, and I hope you have one with centimeters, and I'm gonna measure the diameter which goes across the circle through the center. If you go higher or lower than the center, it will not be an accurate diameter. Now I want everybody right now to go to page 7 and put the name of their object and the diameter they came up with. So everybody do that right now. Go to page 7. So for instance, for mine, I'm gonna write down a teacup or a tea plate. And I'm gonna write down my diameter, which was exactly 14 centimeters.
Mr. Kramer, what is this?
Who is speaking first?
Mark?
Mark. That looks like a CD. And what is the measurement of
It's
the?
not it's not a CD.
Do you want to tell me what it is?
I know what it is, but it's definitely not a CD.
Okay, Mark, what is the diameter of your CD?
Mr. Kramer, I don't have a thing. I don't know we're supposed to get that. I also don't have a
Inches.
I also don't have a tape measure. Can I quickly go grab those?
Go grab both of them. Isabella, what object do you have and what is your diameter?
I have a glue stick.
Wow, and what's the diameter? Mark, do you have your diameter?
10.5.
10.5 what? Miles?
Actually, 10
Yeah.
centimeters.
Is it 10 centimeters? Okay, so 10 centimeters. And now let me just keep asking people. Kelsey, do you have an object?
Yes, I'm using the base of this cup.
Say it louder, please.
I'm using the base of this cup.
Okay, so Kelsey's cup, and what is the diameter?
24.5 centimeters.
Ooh, I don't think so, kiddo.
24.
That looks like a very, very small diameter cup. Hold up the cup and let me see your measuring tape up against the diameter.
I think she's using inches.
No, definitely not inches, because inches are actually bigger than centimeters. They would be 2.5 times less inches than centimeters. So Kelsey, go back to the drawing board. And Penny, what's your object?
It's tomato can.
Okay, so Penny's tomato can. And what is your what is your diameter? Say it louder. Somebody else is speaking at the same time.
10 centimeters.
Say it one more time.
10 centimeters.
It's 10. Okay, good. Everybody write down 10. Now, Avery, do you have one?
My CD is 11 centimeters.
So we have Avery's CD is 11 centimeters. Sarah, do you have something?
Yes. I have I'm using the top of this cup and it is 7 inches.
Uh-oh. Do you have centimeters, honey?
I mean 7 centimeters. 7 centimeters.
Way different. And Alexander, what do you have? Alexander.
Sorry, I was unmuting myself.
I know, you should keep yourself unmuted. That way you don't have to do it. Now, come on, go Alexander.
14. No, let me.
Okay.
My coaster is 7 centimeters.
7. Awesome. Isabella, did you figure out the glue stick?
9 centimeters.
centimeters. There's no way. Honey, let me see that glue stick. Yeah, I want to see you measure that diameter. Show me the actual ruler against the diameter, because that's not it. 9 is going to be way too much. Jack, what do you think?
Well, I have a bowl and it's 14 centimeters.
Not it. The diameter of your bowl is 14 centimeters. Kelsey, go.
When you mean the diameter, do you mean the bottom or the top?
Okay, I want you to look at it again. There's no bottom and there's no top to a diameter. The diameter runs right through the center of your circle. It is this segment that runs.
How much mine is?
Okay, now I want to go with, hold on a second. I want to go with Maeve now.
Mine's a plate and it's 19 centimeters.
Wow, that's huge. That's huge. Okay, who else has not given me theirs? William, iPad, William, iPad, William, go ahead, buddy. Okay, how about the other William? Go.
Unmute, please go.
My bowl is 40 centimeters.
Wait,
Asking you what your thing is. Go ahead, bud. You got to do it, bud.
William.
My bowl is centimeters.
It is definitely not 40 centimeters, buddy. I want you to measure the diameter, not the perimeter, the diameter through the middle. Now I want to go with William's iPad.
I did a plate.
Okay, what is the diameter of the plate?
27 centimeters.
27 centimeters. That is a very, very big plate. Can I see the plate? And I can't see it yet. Looking for it. Okay, I want you to, yeah, you know what? That looks about right. That looks about right. Nice job. I'm going to go with Jonah, Mark, and Sunyi.
Now I just have to figure out what 27 times.
I have a bowl.
Point one four, right?
It is.
Measure it again. Is it
And
27
my bowl is
centimeters?
12 centimeters.
Right?
I don't see the centimeters.
And what about you?
20,
Oh, then 7.
27. Yeah, you got it right.
And what about you, Tess?
Do your math. Right?
Oh, somebody's talking at the same time. You can just wait 1 second or mute yourself. And Tess, what about
Yes.
yours? Go ahead, Tess. Tess, can you hear me, Tess? Give me a thumbs up if you can hear me. Give me a thumbs up. It's very dark there. Okay, I see your thumb up. We can't hear you. Fix your computer, please. Get some sound, and then you can share. Okay, I'm gonna go with Sunyi now. Sunyi,
I have a plate that is 11 centimeters.
all right. And who have I missed? Tess? Bayram? Who have I missed? Just say your name. Say your
Mark.
Gabby.
Mark.
Okay, Mark first. Mark, what do you have?
My diameter is 10 centimeters, but what do I do after that?
Well, oh, Mark, you were 10, and you already gave me that, Mark. Gabby, go.
I'm doing a tape roll and it's 10 centimeters.
And
For the diameter.
and Tess, are you able to get sound yet?
I measure mine again. Mine is 14 and a half centimeters.
Who is 14 and a half?
Me, William.
Me, William. The bowl is 14 and a half. That's great. And I think what we're gonna do, hold on a second. I think what we're gonna do is we're gonna go with 14 for the moment. but I still need Tess.
Mr. Kramer gave me.
Oh, Hayden. Go, Hayden.
I have a bowl and it's 6 centimeters.
Okay. Now, I think
Pi.
we have Isabella, I still don't have your glue stick.
I think it's 2.
I think 2 sounds a lot better. And Kelsey, did you give me yours already?
Pi. Let's find a pi.
Give the
Yeah.
measurement. Is it 7? Enough? 7?
Kelsey, can you speak much louder for me?
I think my cup is 7 centimeters.
All right. Now, everybody now look at Mr. Kramer's screen. My diameter was 14 centimeters. So what I have to do is we're going to first figure out how many diameters fit around the circumference of a circle. Who can tell me how many diameters can fit around the circumference of a circle? That is 1. Raise your hand if you know. Raise your hand if you know how many diameters can fit around the circumference of a circle.
3.
Anybody know? Well, it's 3, but there's a little bit remaining. Remember,
3.5.
it is not a
3,
half,
1.2.
it's
3, 1.7.
3.1.
or a really good estimate is 3 and a 7. That is the number pi. So everybody now, look at what we're going to do. We're going to take Mr. Kramer's diameter of 14 centimeters. We're going to multiply it by pi, which is approximately 3 plus a 7. Now I'm going to use distributive property. Who can tell me what 14 times 3 is? Don't say it out loud, please.
14
Everybody
groups of
write it
3.
down. Everybody write it. Don't say it out loud. Don't speak. Don't
It's
speak. No, don't say it out loud.
question
No,
4 times
no,
3.
no. I want 14 times 3 or 14 plus 14 plus 14 is Avery. Go.
42.
And now, what is 1/7 of 14? Don't call it out loud. Think to yourself, how many 7s divide into 14?
2.
On 3. 1, 2, 3.
2.
2.
Therefore,
4.
our estimate for Mr.
44.
Kramer's circumference is 44 centimeters. I'm going to write that down.
44.
This is my conjecture. Now, I want you guys to watch Mr. Kramer check the math. What I have to do is I'm going to angle my plate. Where is it? Hold on. I'm going to angle it down. So you should be able to see my plate. And I'm going to take a flexible measuring tape and I'm going to measure around the circumference. And I'm going to see where the beginning meets what number. And guys, you would not believe it, but it's exactly 44 centimeters. Exactly 44 centimeters. So the number pi is truly amazing. Now I want all of you to do the same thing.
Pi.
What I want you to do is, for instance, take Kelsey's cup. Kelsey's cup is 7. 7 times 3 is what?
21.
And 7 goes into, so 1/7 of 7. 7 goes into 7 how many times?
One.
Therefore, our conjecture, our guess, is that Kelsey's circumference is going to be 22 centimeters. And your job is everybody should go down the list, figure out the conjecture, and then do the actual measurement.
You can't do the actual measurement because we don't have what the other people have.
All you have to do is your own.
Oh.
Do the conjecture for everybody's, and then do the actual measurement for your own. Now, believe it or not, I'm going to give you everybody's data. So right now, guys, in front on your screen, you have everybody's data. Except Tess. Tess, can you, because we can't hear you, Tess, can you send a chat right now with your number? Can you send a chat with your object and your diameter?
I got 33 and you're supposed to like do how many goes into
everybody,
it.
Guys, Tess has a plate that is 22 centimeters. Wow, that is huge. That's a big plate, Tess. So I'm really glad that you told me it's a plate that is 22 centimeters. And now everybody get to work.
My frisbee is 77 centimeters.
Oh, wait, who is that?
Mark.
So Mark has another item, which is frisbee, which is 77 centimeters across.
No, I'm talking about the circumference.
Yeah, but dude, what's the diameter?
9.
Yeah, so we don't want your circumference right now. We want your diameter so we could figure out your circumference.
I got 33, and then you're supposed to like do how many goes into it, or like how many.
Wait. Who is speaking?
Avery.
So Avery, I want to go to your item. You had a CD. First of all, you did 11 times 3 was what?
33.
And now you have to say, how many times does 7 go into 11?
Well, I can't hear anything that I'm saying.
How many times, Avery, does 7 go into 11?
Okay. It only goes in there once.
Exactly. So it's a little more. So it's 1 and 4/7. So it's about 1.5. So Avery, what is 33 plus 1.5?
34 and a half.
Avery, that is our conjecture. Now do the actual measurement.
How? Like how?
You have to take a tape measure or a string, and you go around your circumference until it matches up.
Let's see here. Let's see first. What's the circumference again?
Circumference is the perimeter. It's the outside. It is exactly pi diameters, 3 1/7 diameters. If anybody has a question, this is a great time to ask it.
Mr. Kramer.
Go ahead, wait, well, hold on. Sarah first.
I have a question. So are we supposed to just do ours? I did some of the math for the other ones because maybe they I could do some of them, but I got caught.
One.
So,
One. Yeah, and by the way, I want everybody to do everybody's conjecture. You can't do anybody's actual, but you can do their conjecture. Now, Sarah, which one did you get stuck on?
on Maeve's 19 centimeter plate, I got the times, but I'm not sure what I'm supposed to do. Like, I got the 19 times 3, but I'm not sure what I'm supposed to do after that.
So what is the 19 times 3?
57.
Totally agree. Now, how many times does 7 go into 19? That'll tell us approximately what 1/7 of 19 is.
2 and
It's not
5.
an exact amount, though.
What is the approximate amount? And somebody did an annotation that they need to erase, please. Go ahead.
Wouldn't it be about 3?
Well, 3 sevens is 21, 2 sevens is 14. So why don't
So
we
we-
say about 2.5?
2 and
And so
1.
57 plus 2.5 is what?
59 and a half.
That is your conjecture. Who else got stuck on one?
I did.
Okay, I think that's Hayden, right?
How do you
Yeah.
measure this?
Which one did you
How
get
do you
stuck?
measure like
I was doing 9, and so for 6 centimeters times 3, I got 18.
Nice.
But then 7 only goes into 18 twice, but there's some.
No, you're not doing a 1/7 of 18. You're doing a 1/7 of 6. 6 is your diameter. So 3 of them is 18, and a 1/7 of 6 is close to what number?
how do you measure the outside of this?
Wait, did somebody just speak over my conversation with Hayden? Hold on one second. Okay. So Hayden, how many times does 7 go into 6 approximately?
0.
Approximately. Come on, really close to what number?
7, so 1.
1. So it's going to be about 6. It's going to be exactly 6/7, but we're going to say 1. And so 18 plus 1 is?
19.
That's your conjecture. Now do your actual. Okay, somebody else just started asking a question about how to do the circumference. Identify yourself and ask me the question. Go.
I did. But like how do you measure
Oh, wait,
this?
you'll have to use identification like your name.
Avery.
Excellent, Avery. So, Avery, you need to take some sort of a flexible ruler. Look at what Mr. Kramer does. I have a flexible string or a cord, and I measure it around the circumference. And that's how I find.
Like this?
Well, hold on a second. You're gonna have to put it on a flat surface, Avery, and then use a cord or a string to measure around the circumference.
Okay.
All right. Who else would like to tell me a problem that they had on one of their conjectures? Okay, so here we go. Everybody look at Mark CD. What's the conjecture on 10? On 3. 1, 2, 3, go.
30.
No, 30 is only 3. It's 3 and a 7. Come on, did nobody else do Mark CD?
31.
It's 31. Yes. What about Isabella's glue stick? Come on, everybody yell it out.
6 and 2/7.
Ah,
6 and
very clever. 6 and 2/7 is the actual. I love it. How about Penny's tomato can?
31 and 3/7.
That's actually even better than my 31. But let's go with 31 for now. Now, Sarah's cup. Everybody, on 3. This is the easiest one. 1, 2, 3, go.
22.
22.
22 centimeters. Alexander's.
22.
Jack's bowl. No, nope, nobody interrupt.
44.
Jack's bowl.
44.
I have to go.
44.
Okay, Barham, take care, buddy. Okay, let's do Williams bowl now. Come on, Williams bowl. On
Oh,
3, 1, 2, 3, go.
44.
44.
Excellent, excellent.
Four.
How about Williams plate,
That's you. Unmute.
which was the biggest plate I've ever seen?
Well, you did it somewhere. Where's your map? Where'd you
Ew,
do it?
82.
Whoa. If somebody got 82, they got close. But 3
Give me the answer.
7 is 81.
Raise your hand.
81.
Hold on. I had to mute you, William. 81 is 3 27s, and 7 goes into 27. How many times, everybody?
3.
A little more than 3. So about 3.5. So our conjecture, William's iPad, can you unmute yourself now and tell me what you think?
84.
I agree. I would write down 84 and maybe even 84 and a half. Okay, Mark's Frisbee. Who's got it? On 3. 1, 2, 3, go.
77.
Oh, 9 times 3.
I didn't see
27. And 7 goes into 9 a little more than 1 time. So it's approximately what, guys?
28.
28 centimeters. Now, Jonah, 12 centimeters times 3 is what, guys?
36.
And then 7 goes into 12 about how many times?
Start. This ends. Just start your video. Okay, well.
Okay.
Come on, 1 and a what?
What do you mean I start?
1 day.
1 and a half. So everybody say it. Jonah's, go. Come on, guys.
37 and a half.
37 and a half. Now, what about Sunyi's plate? What is 3 times 11? Go.
33.
It is 33. And how many times does 7 go into 11?
To 11.
Come on, guys. How many times does 7 go into 11?
Oh, that's 1.5.
About 1.5 times. So 34 and a half centimeters. What about Tess? 22 centimeters. Come on, guys. On 3. 1, 2, 3, go.
64. 66.
66 plus 7 goes into 22. How many times? 7 goes into 22. How many times?
3 and 1/7.
No, just 3.
Our conjecture is 69 centimeters. Now, Gabby, at 10 centimeters, what is her conjecture? Go.
31.
31 and a little bit more. Now, I want everybody to give me the actual circumference. Mark's.
I could figure out mine.
Wait, who said that?
I or Avery.
Avery, you're still trying to figure out your circumference?
I'm trying to figure out how to like do this.
Well, what I do, Avery, I'm going to show you something. I'm going to take out my iPhone cord, okay? And Avery, I'm going to use my iPhone cord, and maybe this will help you, okay? Is everybody watching? I'm going to take my plate, and I'm going to start at the beginning of my iPhone cord, and I'm going to wrap it around. It's hard to do in the air. It's easier to do on a surface, Avery. And I'm going to wrap it around until I get all the way to where I started from. Avery,
Like
you
this?
see it.
This
Avery,
is
you
what
see it.
happens when
Yeah, now
this is
Avery,
what
watch
happens.
this. I take my plate away and I hold that spot. Then I take this segment and I put my ruler on it and I measure the distance from one finger to the other. Go ahead and do that. Okay, here we go. We've only got time for a few. Mark CD. Mark, what was the actual number?
31.
Wow. Excellent. Isabella, what was the actual number? Isabella. What was? Go, Isabella.
Dad, mine was 84 and
Everybody
67.
quiet except for Isabella.
6.
Awesome, honey. Awesome. How about Kelsey? Be ready with your circumference, everybody. Go, Kelsey.
Is it
Kelsey, we'll come back to you, honey. Penny, what was your number?
22?
Oh, good. Kelsey's was 22. That's exactly what we got. Penny, what about yours?
31.
Awesome. Avery, do you have it yet?
It went up to like 14 and a half.
Oh, well, 14 and a half plus 20 is 34 and a half. So keep working at it. Sarah, what about yours?
22.
Oh my God. Alexander?
22.
Jack?
44.
That's crazy. How about Maeve?
58.
Wow, that's so incredibly close. Williams Bolt?
I think about 44 and a half.
Awesome. What about Williams Plate?
84 and 6/7.
Oh my God, that's amazing. 84 and 6/7. Come on, go Mark Frisbee.
40. I mean, 40.
Well, if it's 40, the diameter was definitely not 9. So you need to go back to the drawing board and redo your diameter. Jonah, what do you get? Jonah.
Oh, I couldn't find the measuring tape, but now I found it.
All you need is a cord, buddy. Sun Yi.
34 and 6/7.
Wow, that's really cool. What about you, Tess? Oh, Tess, we can't hear. What about you, Gabby?
31 and 3/7.
Oh, that's exactly what you should have gotten. But it's really hard to measure sevenths with centimeters. So I'm not sure where you guys are getting your sevenths with centimeters. And Hayden. Hayden.
10.
Ooh. Now, if your circumference was 10, your diameter was definitely not 6. In fact, I bet your diameter was 3, because 3 times 3 and 7 is about 10. Everybody, you did an amazing job today. You have calculated pi just like the ancients did, just like the ancient mathematicians. And that makes you a very special mathematician. Everybody, I will see you in a week's time. Take care, enjoy yourselves, and be safe. Bye.
Bye.